On the same graph paper below, basically this grid over here, draw the graphs of the following equations. Y equals to 2x, y equals to 2x plus 2, y equals to 2x minus 2. Let's start with the first one first. I orientate you to how this table works first. We've got our x values. Again, x will be our input. What you put into the vending machine will be these three values, -1, 0, and 1. We've got three different vending machines. We've got three different functions over here. Let's deal with just the first one. Okay, we will ignore the rest first. Ignore this. I just want to fill out the first row. What happens when x is equal to -1? So filling in the blanks is not difficult. Y equals to 2 times of x. Every time I see the x, I put in -1. I put brackets, put in -1. Okay, so simple. Y equals to -2. -2. In fact, we don't even need to write the y equals to. So this is what we will see in our table. Okay, do the calculations by yourself. I don't need to see the calculation, but make sure you get it right. Your substitution must be accurate. So y equals to 2 times of 0, simply 0. Y equals to 2 times of 1, that is 2. Simple so far for the first row. Now let's do the plotting. 10 seconds, plot. Go plot, plot, plot. Doesn't take you long. -1, -2. So block -1, level -2. Next, block 0, level 0. That is the origin. Block 1, level 2. Okay. So I want you to plot. How do you plot it? Just join. Just join. Like this? Is this what you have? Yes or no? Yes or no? Yes, yes. Sabrina, yes. No. Why not? How is yours different? I must extend, is it? Yeah, you must extend. Remember, don't just stop at the end points. By default, you go all the way across. All the way. Yeah, unless they tell you from where to where. Otherwise, the default is all the way. I don't care if it is outside of the paper. All the way. I don't care you draw across your name. I don't care. Must be long. Okay, make sure you cover as much as you can. So this is the graph for y equals to 2x. Now I want you to label y equals to 2x. So this is what you should see so far. Fill in the blanks. For the next row, y equals to 2x plus 2. Well, you literally go across the whole paper. Never mind, I like. Okay, now, look. You're done with the drawing of the first graph? Don't be so anxious to do the next part yet. I want to show you something. We try and work smart. The next line says y equals to 2x plus 2. If we do the working, it would be y equals to 2 times of -1 plus 2. Y equals to 2 times of 0 plus 2. Y equals to 2 times of 1 plus 2. Okay? Nothing difficult so far, right? But watch what I have over here. Y equals to 2 times of -1. Y equals to 2 times of 0. Y equals to 2 times of 1. Basically this portion, right? That is the 2x portion. I don't want to talk about the +1 yet. Oh, sorry, the +2 yet. Look at the green color ones. They are the same, isn't it? Is this a repeated calculation? From where? The previous row. You see that? It's the same. This part is the same. Here, look, your 2 times -1 is your -2. 2 times 0 is 0. 2 times 1 is 2. So actually, what we are doing is, whatever answer you got in the first row, we're just going to add 2 to it. your -2 plus 2. What do we have? -2 plus 2 is just 0. Okay, for this value, we have 0. The next value is 2 times 0, which, 0 plus 2. It is 2. Next value, for the same x value, for the same input, I get 4. What is the pattern that you realize? For the same x value, for the same input, how does the first graph compare with the second graph? How do they compare? For the y values, it's just a plus 2. We just plus 2, and it came from this part of the equation. We're just adding 2 for the same x value. Let's see what it means on the graph. The first set of coordinates, let's plot this set, -1, 0. Let's see where it is. Block -1, level 0. Over here. Block -1, level 0. Can you see that these 2 points, this point and this point, they both are in the same block? They both have the same input. It's just that for the first graph, we ended up with level -2. For the second graph, we ended up with level 0. It is an increase of 2 levels. We move up by 2 levels. Let's check out the second point. The second point is 0, 2. 0, 2. Block 0, level 2. You can see that for the same block, it actually went up by 2 levels again. Naturally, for the third one, block 1, level 4, it also went up by 2 levels. So draw a line all the way across. And label. If you do not label, I don't know which graph is for which. So this will give us y. I'll put it. Some people do it this way. Y equals to 2x plus 2. They write it like along the line. Up to you. Different style. And now, let's take a look at the final graph that we have to draw. For the same x input, x equals to -1, we end up with the following values. The 2x is calculated already, just -2. Whatever that value is, we're going to subtract 2 again. -4, -2, and 0. Okay? And see, instantly you can do the calculation because you've already done the first one. But if you want to calculate everything all over again, sure, go ahead. You have a lot of time. So block -1, level -4. -1, -4. 2 levels down for every single point. Draw a line. And the final equation, y equals to 2x minus 2. So these are the 3 graphs. If you do not label, I don't know which graph it is for. And now my labeling also not very good, right? I cannot really tell y equals to 2x belongs to which graph. So edit it. Okay, so here we have y equals to 2x. Okay, now let's answer the first question. What is the shape and direction of the graphs. What are the shapes and the directions of the graphs? So shape, very simple, straight lines. Okay. Shape is all three of them are straight lines. What about direction? What directions do you know? Left, right, up, down. These are directions, isn't it? Okay, so listen carefully. Look at the screen. Ashton, very distracted. Now, direction. Always go from left to right. That's natural, isn't it? You read from left to right. Smaller number on the left, bigger number on the right. It's very natural to go from left to right. But in this case, when we talk about direction, looking from the left to the right for all three graphs. Let's start with the first graph, the original graph that we drew. From left to the right. For the first graph, left to the right, we are actually going diagonally, right? But we say upwards. From left to right, it is actually going upwards. From left to right, it is going upwards. Same for all three graphs. They are sloping. So the keyword is sloping. Sloping upwards. This is what we expect. They are all sloping upwards. Does that mean that we can have sloping downwards? What would sloping downwards look like? Again, from left to right, this is what sloping downwards looks like. Okay, so when we talk about direction, slope up on the left is like a tick. Slope down, that is on the right. What other directions do we have? It is flat. It is horizontal. We've got vertical as well. These are the four cases you will see. Slope up, slope down, vertical, horizontal. Only this one. So next, what do you notice about the steepness of the lines? What does steepness mean? Do you like to run up a slope for your PE? Do you actually run slopes? No, school no slope. Are there slopes in school? Are there slopes in school? Are you sure to have? No, in school. Let's talk about school. Are there any slopes in our school? Where? Near the general office entrance. Oh, for the wheelchair one, right? Wheelchair access. Correct. Also from at level 2, near staff room 1, when you want to walk the link bridge across to the hall, do you realize that there's a very gentle slope? There's a very gentle slope over there. So slope has got to do with the steepness. We in a classroom, we are on level ground. It is horizontal in our classroom. When you are talking about climbing a mountain, there is steepness involved. We are going down a mountain, there is steepness involved. So how steep it is will depend on something. What about these three cases? The three yellow lines. Do they have the same steepness? Do they have the same slope? Are they just as difficult to climb as each other? Yes, right. They all have the same slope. This is a key word that you must understand. Pauline, okay? Same slope, huh? Same steepness. Can you also describe to me using a primary school word that you have learned? A word that you have learned in primary school for these three lines? Not diagonal. Something that describes these three lines. Parallel. If they are parallel, they have the same slope. Do you agree? Does it make sense? If all the ground, all the floors in the school are parallel, level 1, level 2, level 3, level 4, if they are all parallel, if we extend, they will not meet each other. But today, of course, they meet each other because we've got staircase, which is not parallel. Okay, if they are parallel, they go on and on forever, they will not meet, meaning they have the same steepness, same slope. Okay, now, what do you notice about the steepness? Same steepness. Let's write that down. Same steepness. Okay, what else did they say? What do you notice about the coefficient of x? Yeah, what is coefficient? If you forgot, never mind. We will discover it in a while. So you notice that these three graphs, they are different graphs, but they have something in common. They have the same steepness, but they are different graphs. Let's go back to the equation. The three equations. Is there something in common for all of them? What is common? They all have y. Can you see that? They all have y. Okay, they all have y. What else do they all have? 2x. They have a 2 and they have an x. The similarity between these three physical graphs is that they have the same steepness. This same steepness can be attributed to something that is the same in the equation. What do you think out of these three, y, 2, and x, which one do you think contributes to the same steepness? Is it the y that makes them have the same steepness? Or is it the number 2 that makes them have the same steepness? Or is it the x that makes them have the same steepness? What do you think? Okay, I've got one answer. 2. What about the rest? X. Is it an x? What else? Is it a y? So we can just do a very simple thought process. Very simple thought process. What if I were to change the y? What if I change the y to become something else? For example, 3y. And then I keep everything else the same. Equals to 2x, for example. Will I get the same? Will I get the same steepness? You can go and plot and see, no? You can go and plot and see whether you get the same steepness or not. Hey, you know, plotting takes a lot of time, right? Let's use a software. We've got Desmos. Okay, let me share the correct screen. Oops. Okay, this is the website, DESMOS, my favorite graphing calculator, because it saves me a lot of effort from plotting. So we were dealing with three graphs so far. Y equals to 2x, y equals to 2x minus 2, 2x plus 2. Them down, y equals to 2x. Okay, that's the first graph we have. Y equals to 2x plus 2. Second graph, blue color. The graph, y equals to 2x minus 2. As expected, parallel. Don't meet each other. No matter how I zoom in, zoom out, they will not meet each other. So we were talking about, what if I change it to become 3y equals to 2x? 3y equals to 2x. Does it have the same gradient? Does it have the same gradient? Don't have the same gradient. Obviously, it cuts. It is not about the y. So we were also suggesting, maybe it's the 2 that makes them the same steepness. Let's keep the 2 constant. Let's change it to y equals to 2x. Give me another number. Something bigger. Let's say minus 10. You see that? Y minus 10. I kept that 2 in front of the x common. By keeping that 2 constant, I ended up with graphs that are parallel. Let's try more. Let's try more. Other numbers. Y equals to 2x minus 0.136. Very, can't even see it. Okay, see the one that's very near? This one. Still parallel. It is the 2x. It is the number 2 that makes them have the same coefficient. Okay? So, in summary, we are saying that in part C, it has the same steepness and same coefficient. Same steepness, same coefficient. So coefficient, again, to remind you, is the number that is found before the variable. So for example, what is the coefficient? What are the coefficients of x? To answer this question, let's go with part A, find x. Answer? part B, negative 3x, cancel 3 negative half x. So what is the first answer? 5 is simplified. The coefficient is 5. We are talking about the number in front of the x. So what is the coefficient over here? Negative 3, simple. Finally, negative half. When the coefficient of x is the same, for now, we have the same steepness. Okay. Later we see how we make things more difficult for you. So in this case, what is the coefficient? Coefficient equals to 2 in this case, this particular case. So from B and C, what can you conclude? Okay, what do we conclude? Same coefficient of x implies same steepness. The same coefficient of x implies the same steepness. Okay. Next one. Anybody needs more time? I heard a distress call just now. Hey. The next one, exercise number 2. On the same graph paper, okay, very similar type of question. Now let's fill in the blanks very quickly. For the first row, y equals to 1/3 x plus 1. So 1/3 times negative 3 is negative 1 plus 1 is 0. 0 times 1/3 is just 0 plus 1 is 1. 3 divided by 3 is 1. 1 plus 1, that is 2. Okay, let's plot the first one. Block negative 3, level 0. Block 0, level 1. Block 3, level 2. Join to get a first graph. All the way across again. And of course, label y equals to 1/3 x plus 1. Next graph, negative 3 plus 1, negative 2. 0 plus 1, 1. 3 plus 1, 4. Plot your next graph. Block negative 3, level negative 2. Negative 3, negative 2. Block 0, level 1. Oh, it is the same point. Same cross. Next, block 3, level 4. Join them up. This is my graph of y equals to x plus 1. The final graph. 1 plus 1, 2. 0 plus 1 is 1. Negative 1 plus 1, 0. 2. Again 1 and 0. Join them up. So these are the 3 graphs with the labels clearly shown. Okay, you use some time to finish this up. Out of the 3 graphs, how many are sloping upwards? How many? 2 of them are sloping upwards. What do you notice about the coefficients for these 2 graphs? You said 2 sloping upwards, right? What do they have in common? What do the 2 coefficients have in common? They are positive. You just discovered something for yourself. Positive coefficient of x implies sloping upwards. Okay? Then, by the same logic, the one that is sloping downwards should have a coefficient of x that is positive or negative. It is sloping downwards. Negative. Okay? So, slope up, coefficient is positive. Slope down, coefficient is negative. So this proved to us earlier on what we just discovered. Coefficient of x is the same, same steepness. Coefficient of x is different, different steepness. But the other point that we want to point out over here is that, do you see that these three graphs they all meet at one point, one very special point. What are the coordinates of this point? 0, 1, as shown over here. Hey, why did that happen? Is it a coincidence? Think through your working. What happened over here? At x equals to 0, what happened? What happened at x equals to 0? 1/3 times 0 is 0. X equals to 0. Third case, negative 1/3 times 0 is 0. All the highlighted values became 0. And then what happened after that? Yeah, all of them became the same. 0 plus 1, 0 plus 1, 0 plus 1. So what caused all of them to meet at the same point? It was the x equals to 0. When x equals to 0, all these became 0, leaving us only with the final value, the final number, which is plus 1, plus 1, plus 1. And that was how we ended up with 1, 1, 1. And that is why we say that when x equals to 0, y equals to 1 for all three cases. There is a special name for this point. It is known as the y-intercept. So let's answer part B now. Where is the point that they all meet? It is point 0, 1. 0, 1 is where they meet. But when they ask you for the y-intercept literally means where is your y-axis intersected? Where does it intersect the y-axis? When you are on your way to school, then your friend intercepted you. It means that your friend met up with you along your way to school. So intercept over here means where they meet. So where do they meet? The y-intercept has a value of 1. Okay, take note. Why do I put stars? Because although you may understand the concept, but you may not be familiar with the vocabulary. What is the common mistake? So for good students, wow, they pay attention, but vocabulary not good. They will say y-intercept equals to 0, 1. This is wrong. Okay, please be very careful of how you answer. 0, 1 is the point. It consists of two parts, x and y values. When I ask for y-intercept, I only want the y value. This is the y value. So what can you conclude about the relationship between the y-intercept and the linear equations? In this case, y-intercept is the, okay, let's look back at our three equations. How will you describe these three ones over there? The ones that are circled in red. What is our name that we can give those three ones over there? You know, we had one word, right? Coefficient. But these are not coefficients. What are they? They are the constant terms, yes. Constant terms don't have x. They are just by themselves. So in this case, it is the constant term. Y-intercept is the constant term. So if the equations were changed to become y equal to 1/3 x plus 100, then the y-intercept will be 100. Whatever that constant term is. Okay, next, how does the coefficient of x affect the steepness and direction? So earlier on, we had two conclusions. We had one conclusion. To answer the part 2, so this part 1, part 2, positive coefficient implies slope up. Negative coefficient implies slope down. But there's one more thing we haven't talked about for the positive coefficient. Let me write this down first. So that double arrow means implies. It has a mathematical meaning for it. Implies. Anybody needs more time? Didn't finish? Okay, so earlier on we said that this has a coefficient of x to be 1/3 as well as 1. Let's focus on the 1/3 and 1. So I'm going to remove the other graph. These two graphs, which one is steeper? Which one is more steep? Okay, both also +1 lah. Okay, so I want you to recognize which graph is more steep. What is the equation of the graph that is more steep? X plus 1. Y equals to x plus 1 is more steep. Can visually see. Very difficult to climb this slope as compared to the other one. So what made it more steep? The value of the coefficient. The bigger the value, the steeper it is. So one last point, write this down. The greater the coefficient, you know what, let's shorten it. Coefficient increase implies steepness increase. Okay? So this is the last point over here. What about your homework? Watch the rest of the video. Exercise 3, 1 video, 2 videos, 3 videos. Yes. Say again. Hang on. So there are 3 videos to watch.